Good evening and welcome to this video on Quotient Rule, and this is for Level 3 Calculus and Level 3 Differentiation. As the name implies, the quotient rule can be used to differentiate a quotient, so that is when a part of a function is divided by another. So for this part of the function, it should be a function of the variable that the function is referring to. So it could be f of x would be two functions of x, so one divided by the other. If it's f of w, then be a function of w divided by another function of w. On the Level 3 Calculus formula sheet, the following is shown. So the derivative of f over g dash is equal to g times of f dash minus f times of g dash over g squared. F and g are parts of a function of a variable. Okay, consider the function f of x equals to x over sine of x. This is a quotient rule because x is a function of x and sine of x is a function of x, and they're divided by each other. So in this case, I've set the numerator function to be x, and I've named this variable as h. You don't actually have to name this variable to be h. You can say it's a, you can say it's b, you can say it's z, you can say it's anything. But just for this specific case, I've set it for it to be h. For the denominator function, that is I've called it g, and that is sine of x. Our formula states that g times of f dash minus f times of g dash over g squared is our derivative. So therefore, our h dash of x is 1, g dash of x is cos of x. So in this case, our g times of our h dash of x will be our first part of the equation. So sine of x times 1 will be our sine of x at the top, minus f times of g dash, so that would be our x times of our cos x. So that would be our x times cos x. So it would be sine x minus x times cos x over sine squared x, as shown in this sine x minus x cos x over sine squared x. So here are some walkthrough examples. So f of x equals to 5 over e to the power of x plus x squared. We're going to write out our numerator function and our denominator function. So our numerator function is 5 and our denominator function is e to the power of x plus x squared. So if we differentiate this, derivative of 5 is 0. Derivative of g is e to the power of x plus 2x. Derivative of e to the power of x is still e to the power of x. Derivative of x squared is 2x. Applying our quotient rule, we'll get f dash of x equals to negative 5 times e to the power of x plus 2x over e to the power of x plus x squared to the power of 2. So how I got this is, if we say our first part of the equation, our g times f dash, that will be our e to the power of x plus x squared times of 0. And anything times 0, that's still 0, so that first part is equal to 0. So all we're left with is negative f times g dash. Negative f times g dash in this case would be e to the power of x plus 2x times of 5. So negative 5 times e to the power of x plus 2x over the denominator squared, which is e to the power of x plus x squared to the power of 2. And that's our final answer. For question 2, we have x plus 1 to the power of 1/2 plus 2x over tan of 3x. So in this case, we're going to be using the chain rule as well as the quotient rule together. We're going to write out our numerator function, that is x plus 1 to the power of 1/2 plus 2x. Our denominator function is tan of 3x. If we find the derivative of each of these, we'll get that h dash of x is 1/2 times x plus 1 to the power of negative 1/2 plus 2. Our g dash of x would be 3 times of tan 3x times secant 3x. So in that case, we would be we'll be using our quotient rule. So we'll have our f dash of g minus our g dash of f over g squared, and the answer should be half of x plus 1 to the power of negative 1/2 plus 2. That's our derivative times of our g, which is tan of 3x, minus our x plus 1 to the power of 1/2 plus 2x, multiplied by 3 tan 3x times secant 3x, all over the denominator squared, which is tan squared 3x. So here are some practice questions, so I want you to pause the video and try these for yourselves. First question is f of x equals to 3x minus 4x squared over 2x squared plus 1. Alright, so in this case, we should get our f dash of x as 3 minus 8x times 2x squared plus 1 minus 4x times 3x minus 4x squared over 2x squared plus 1 squared. So the derivative of our numerator is 3 minus 8x, and our derivative of our denominator is 4x. Our first part of our equation, that would be our derivative of our numerator, which is 3 minus 8x, multiplied by the non-derivative of our denominator, which is 2x squared plus 1. And we're going to minus that we're going to take away 4x, which is derivative of the bottom function. Derivative of 2x squared plus 1 is 4x, multiplied by the non-derivative of the numerator, which is 3x minus 4x squared. And at the end, we're going to divide by the denominator squared, which is 2x squared plus 1 squared. Question 2, f of x equals to 6x squared over 2 minus x. Our f dash of x comes to be 12x times 2 minus x minus 1, so plus 6x squared over 2 minus x to the power of 2. The derivative of our numerator is 12x, the derivative of our denominator is negative 1. So our first part of the equation would be our numerator times the derivative of our denominator. Oh, sorry, other way around. So the first part of our equation is actually the derivative of our numerator times of our non-derivative of our denominator. So that's 12x. That's the derivative of 6x squared. 12x times of 2 minus x. And we're going to take that, so we're going to minus the derivative of the denominator times the non-derivative of the numerator. So the derivative of 2 minus x is negative 1. So minus negative 1 times of 6x squared, that becomes plus 6x squared over the denominator squared, which is 2 minus x squared. Question 3, we have f of x equals to 5 e to the power of negative x over x plus e to the power of negative 2x. Our answer is negative 5 e to the power of negative x times x plus e to the power of negative 2x minus 5 e to the power of negative x, bracket 1 minus half e to the power of negative 2x, divided by x plus e to the power of negative 2x squared. Alright, so for this equation, our derivative of the numerator is negative 5 e to the power of negative x. Derivative of our denominator is 1 minus half of e to the power of negative 2x. Our first part is our derivative of our numerator times the non-derivative of our denominator, which is negative 5 e to the power of negative x times x plus e to the power of negative 2x. Second part will be take minus our derivative of our denominator times the non-derivative of our numerator. So minus 5 e to the power of negative x times our derivative of the denominator, which is 1 minus 1 half of e to the power of negative 2x, all divided by the denominator squared, which is x plus e to the power of negative 2x squared. And the last question we have is f of x equals to square root of 3x plus 2 over 2x minus 1. Alright, so for this question, we're going to be applying the chain rule and the quotient rule together. So our f dash of x, so if we square root can be rewritten as 2 to the power of 1/2. So we're going to take the power down, so it becomes 1/2 times everything in the middle to the power of negative 1/2. Take the power down by 1 times by the derivative of the inner function, which is 3x plus 2 over 2x minus 1. In this case, we're going to have to use the quotient rule. So derivative of 3x plus 2 is just 3. And derivative of 2x minus 1 is just 2. So our first part of the equation would be our derivative of our numerator times by the non-derivative of our denominator. Derivative of 3x plus 2 is 3. 3 times of 2x minus 1, that is 6x minus 3. And minus our derivative of the denominator times our non-derivative of the numerator. So derivative of 2x minus 1 is just 2. So 2 times of 3x plus 2, which is 6x plus 4, all over the denominator squared, which is 2x minus 1 squared. And that's our final answer. Alright, so and that's it for this video. I hope you enjoyed, and I see you all in the next one. Thank you. Bye.